So today we are going to do sampling, and you've heard this kind of word. This is not the first time, but simply, if you have a very huge population or any population that you would like to study, it may not be that ideal that you pick all the participants or you pick the whole population to study it, but you can pick out a portion from that population, and that portion that you picked should be a representative of the whole population. So when you do research on that sample or on that small group, it is then you can infer, you can generalize that this what I've found from this small group, it is actually uh, a whole picture. It's actually the pictorial image of the whole population. So that small group that we pick from the population that we have to study is what we call a sample. Okay, so it's a small group of individuals from a large group of population that you would like to study, okay? Or what your research focus is about. But as you try to select this small group from the population, there are methods that use, there are techniques that use, and these techniques actually are so important in a manner that they can determine the accuracy, they can reduce on the bias of your research, because you have so many biases. Give an example of selection bias, okay, and sampling bias. So if you the techniques, if you follow them very well, your research should be minimizing. This research will minimize those biases I'm talking about, the selection bias, whereby the selection of your participants into the study was not random. Okay, so that causes for a selection bias. So for non-probability sampling, or when you sample a population whereby the manner of picking your participants is not based on probability, it's not based on chance. That is what we call the non-sampling method of sampling. And examples of non-sampling, that is one of them is auto sampling, selection, self-selection sampling, convenience sampling, snowball sampling, and purposive sampling. Okay. However, when you try to select population and every participant in that population has a chance to participate, meaning the selection is based on probability, then that is what we call probability sampling. And the types under there or the techniques is simple random, a systematic random, a stratified random, and cluster. You see that all these have something to do with random, 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 meaning all the participants have the chance. Each participant has a chance to participate in this study. Okay, I hope you can hear me very clearly. That way. So let us discuss the probability sampling technique. Okay, so one of them is what we call the simple random sampling. Okay. You remember when we used to play long time ago, and then you get some small papers, write on your names, and then put them in a small file, and you'll be like, we only want around only 5 people to participate, but you're around 10. So you pick out each paper from the bowel, and you want to only pick 5 people out of the 10. Okay. So the bowel is consisting of 10 people, but you want to pick only 5 or 3. So you pick 3 papers after the shuffle. Then those 3 papers you pick, you open the names, and then those are the people that are going to participate in the play. So that is what we call simple random sampling. However, there's what we call simple random sampling with replacement, simple random sampling without replacement. So with replacement, when you pick out, give an example, all of you, when you are on your names are written on the small paper and the papers are put in a bowl. When I pick one paper, okay, and I read that, oh, Mr. Chimera, then I can roll it and put it back in the bowl. Then I again shuffle. I pick another paper, Mr. Hussein. Then I again roll it. So I'm writing Mr. Hussein, Mr. Chimera side, but I'm putting their names back into the bowl for selection. So that is what we call For random with replacement. So as you pick out the participant has a chance to participate in the second selection, in the third selection, and even in the fifth selection. Okay, because you're repeatedly putting his name back into the bowel. So the ways of doing this is lottery. You've had this lottery whereby lottery or envelope method. Envelopes are put aside, and then one are picked at once, and those like what you've seen in these winning competitions. Okay, all of you cast in your mobile numbers, and then the numbers are shuffled, and then one number is picked out, and that is the winner. Okay, so that is lottery or envelope method. Then we also have what you call random number table method. Okay, now random table number method is the one like in Excel. Okay, I can assign a population of 1,000. I number one up to 1,000. Then I put those numbers in Excel. But when each number I have attached a name of someone. Okay, number one, Munir. Number two, Godwin. Number three, Mr. Chimera, Lydian. Number four, Mr. Number five. So thousands of people. Then I put numbers into Excel random generator. Then I tell Excel, I put a code there to only get me only 102 participants. So the Excel number is going to generate for you random numbers. And those random numbers are going to be your participants. So you'll pick 89. That was who? Mr. You remember your population was 1,000. Then you can pick 145 as one of the generated numbers. You check who is 140. So that is what we call random number generator. You get the numbers inside, and then it generates for you the numbers, and those numbers you correlate to them to the participants of interest. So selection is purely based on chance. Okay, for simple random, it's a probability sampling technique. So how about the systematic? So systematic random sampling is also non-probability sampling. But here the participants are selected at a fixed interval. Let me give an example. When you are doing a study in antenatal, okay? Then you'll be like, for every third mother, every second mother who comes, is the one that is going to participate in the study. So you sit at the registry point. So mother number one comes, that one goes. Number two, I'll take number two. I'll miss number three, take number four, I'll miss number five, take number six. So that is what we call systematic sampling. It's a probability sampling techniques, and it is also it allows for selection of participants in that manner. Okay, I hope that one is also clear. So it is different from the simple random. So there is also what we call the stratified strata. So stratas are just small groups, okay? But these stratas are based on, they can be based to age, sex, profession. So I can say, I'm going to do a study, but this time round, I'm going to classify my participants in terms of profession. Nurses, medical officers, physicians, midwives. So after forming that strata from health profession as the population, then I'm going to randomly select from the strata of midwives. I only want 5, and midwives are 10. So I can employ simple random technique to pick out the 5 midwives from the 10. Okay, I hope that one is now clear. So under stratified random sampling, you have proportionate, whereby each strata has equal numbers. I'll pick 5 midwives, 5 nurses. So each strata has equal numbers. The strata for midwives has 10 midwives. Medical officers are also 10. Physicians are also 10. Okay, you're getting equal numbers in each strata. And the non-proportionate is when those strata the numbers are not the same. Okay, the strata for doctors maybe has 5. Strata for nurses maybe has 10 or 15, because nurses usually be midwives, like that. So a population is divided into what we call strata under stratified, and the population, the example I've given you is health care workers. Okay. And then after making those strata at side, then you can select participants from those strata randomly. Okay. Using simple random, like I've showed down there. Then you have what you call cluster. Cluster is different from strata. You realize that strata are already, you generate them, okay? But for cluster, they are naturally existing, okay? So that is the difference I want you to pick from here. A cluster, the group is already there. Give an example, family. That is a cluster of family. You know which, the number of, you know how a family is defined. Community, a society, okay? Town. So I could be studying, and then in my methodology, I say I'm going to stratify the villages. Villages were stratified in Mbale. Villages of Mbale district were stratified. So I'll pick villages and stratify them. The Mbale is the whole group. Then I'm going to pick villages as my cluster. Nakaloke, Namanyoni, okay? Or let me give an example of Kampala. Kampala, you stratify the city, okay? City of Kampala is going to be stratified. So when your strata are going to be Machindi, Mengo, okay? Your clusters. Clusters are going to be Machindi, Mengo, Katwe, Mulago, okay? So now under those strata, the cluster, oh, I'm getting the strata on my tongue. So under the clusters, okay, of those divisions in Kampala, so those clusters are going to we're going to apply simple random or systematic random to select which ones are going to take part in your study. Okay? I hope that one is also clear. And also after that, you can also even go ahead and even participants in those cluster also randomize. So you're trying to show your study that you're trying to eliminate the sampling bias and selection bias in study. Remember, bias means that if I say the study is biased, it means there are some procedures that you actually didn't follow. And these procedures are actually affecting your results. So your study is now biased. And those procedures could happen in the selection, could happen in the design, could happen in the confounding. When you didn't cater for confounding variables are those variables that can interfere with your study independently. Okay? Give an example of when you're studying the study that I've been trying to appraise, which says that footballers or soccer players were also the position, midfielders, defenders, and goalkeepers were associated. Playing in those positions was associated to neurodegenerative disorders. Mr. Chimera can understand this very well because he's a psychiatrist. Okay, so that playing as a defender or defenders were at a very high risk of developing neurodegenerative disorders as compared to goalkeeper. Okay. Now I want to show you that in this study they didn't capture the matches played by these these are persons or these people in these positions. And when I was appraising this study, I told the author that why didn't you add the number of matches, because number of matches increase the frequency at which these people were exposed to collisions, to head injuries, which are actually associated to neurodegenerative disorders. You get it? So the number of matches was a confounding. It is a factor that was affecting probably the outcome, which was neurodegenerative disorder. So if you don't cater for that, if you don't write that one somewhere, it can be a confounding variable and it can cause what we call confounding bias. We shall discuss bias at some time T on as its own entity. So let's now go to the non-probability. Non-probability one of the one we want to right now look at is the purposive sampling, whereby the selection of the participants is based on purpose of the study. Okay, want to study antenatal mothers or mothers who are attending antenatal or pregnant mothers. So that is purposive. Based on my study, I want to only study pregnant women. Okay, based on that purpose of the study. So it is a non-probability sampling technique. Okay, and the results are focused on only now that group that you picked, which is pregnant mothers. So there is also what you call convenience sampling. So this one is, as it says, it's based on convenience of maybe access. And usually what usually students do is convenience because you don't have the finances, you don't have the access to mothers who are probably living far you. So you conveniently select mothers within the locality of your reach. So that kind of sampling is called convenience sampling, and it is a non-probability sampling technique. And probably you're doing that, or researchers do convenience sampling because cost effective, it is less time consuming, and it has simple operations. You just be like, I will take all mothers that will come. I'll consider only mothers who stay in Kampala because it's you stay in Kampala. So why would you go for mothers in far rich area? So that is convenience sampling. Another one is also non-probability called Snowball. So Snowball sampling, the first participant will now identify the other respondents into your study. Okay. The example I usually give is when you're studying maybe youths who are HIV positive. So you pick one, and that one youth will now keep on calling other youth into the study because they usually have that connection, that that linkage. Like if an HIV youth is taking medicine from here, that unit usually tries to connect with other youth so that this other youth probably is not stigmatized, something like that. So when you're doing such a study, you may identify only one participant, and this participant can connect you to other respondents for your study. So that is called snowball sampling. So we also have what we call the quota sampling technique. It is slightly similar to stratified. However, in the quota sampling technique or quota, whatever pronunciation you may have, the participants are not randomly selected. You remember I said when you form a strata, okay, of nurses, and then you want to pick only 5 nurses from the 15. So in a quota sampling technique, you only pick without sampling them. You only be like, every nurse who comes very early in the morning, no, all the nurses, I'll consider nurses who are there in the morning. You get it? Who will work day duty, who will work night duty. Okay? So you've not selected, you've not randomly selected. So not every nurse on the ward had a chance to participate. Okay? Or you go to the ward and then you just ask, are you a nurse? You give that one the questionnaire. Are you a nurse? You give the questionnaire. Are you a nurse? You give the questionnaire. So you didn't not every nurse had a chance to participate. So it was not on a probability selection. So that is the difference between quota sampling and stratified. For stratified, you randomly select the participants, but here after forming the small group of the strata, you don't